Hi, I'm Alan Ross. I'm the managing editor of APC Media and APC Technologies. We are at the Seagray 2023 Grid of the Future Symposium. And these interviews are with the leaders at Seagray and the leaders of the industry. Hope you enjoy. My next guest is Amanda Olson, Mandy Olson. Thank you for letting me call you Mandy. That means there's a simpatico. Mandy is the engineering director at Burns & McDonnell, and you've been doing it for 14 years, so you got in it, never left it. We're going to talk about that. But how did you get involved with Burns, and how did you get involved with engineering in the first place?
I actually just told this story yesterday to a bunch of Girl Scouts.
Okay, that's cool.
Yeah, so I grew up in a very small town. Was the first one in my family to go to college, and honestly had no idea what engineering was.
Yeah.
I was a high school professor that said one day, Mandy, you're good at math and science, and I think you should look at engineering. And that's when I was like, what's engineering?
Good for him.
Yeah, no, I don't think teachers fully, I wish I, in that instance, would have gone back and thanked him for that because of the impact that it had on my life long term. But that's really how I started digging into engineering and quickly realized the volume of problems that engineers get to tackle every day. But I went to Missouri University of Science and Technology. I went in with undecided engineering because learning about it for the first time, I didn't know what I wanted to be. What type of engineer? That was the thing.
And you had to pick.
You had to
pick. So I picked AE. And then I had a professor. So he said, Alan, planes fall out of the sky if you don't do your job. I think you ought to switch. I switched to mechanical engineering. True story, by the way. True story.
That's incredible. Well, I got to pick electrical because of a test that I took my freshman year, just basically like an interest test.
Yeah.
Where you might have aptitude or where you might have an interest naturally. And electrical was my recommended outcome with that exam. And so that's what I went into, and I haven't looked back ever since. I joined Burns & McDonnell as an intern. So I was still in college. I interned with them for 2 years doing substation design. And then I started full-time in 2009. And for a long time, I did substation design, physical system protection, and became a project manager. I really enjoy leading people and building teams, working towards common goals. And so that's what eventually led me to the role that I'm in now, where I get to focus a lot on the operations within our transmission and distribution group from a technical perspective. So helping us as we grow and scale our business, making sure that we are delivering the highest quality products to our clients in the most efficient manners.
That's a great commercial. For Burns & McDonnell's and what you do, and that's fine because this is non-commercial. But I want to talk about now, because you, in your time, you have seen probably the most change that we've seen in the industry since 100 years, right? So it's an exciting time to be in the industry. As a result of that, we've got digitalization, decarbonization, diversification. Another D. I try to pick the D's because I can remember them. Anyway, we've got this demand change, not demand with power, but demand change. We've got ratepayers who are now prosumers and consumers. We've got DER. We've got the step down grid being a step everywhere grid, right? You see all that. In your role, you see all that. What are some of the most significant problems that you've seen that you've had to overcome?
It's where to start. And I look at problems as opportunities.
Right. That's a great one. Pick one.
So I will start from a people perspective.
Okay.
I think while we're in the midst of all of that change, we're also in the midst of, we have a lot of people transitioning out of the industry that are our experts, and dealing with how do we transfer that knowledge seamlessly and quickly at a time when we need it most. Because we are, even though we don't have enough engineers entering into the field, we're entering more than are exiting. And so making sure that we have that intentional mentorship to really develop the skills that it'll take to implement all of the changes that are required on the grid today from a equipment perspective, an engineering perspective, a construction perspective, all across the board, I think people will continue to be a limiting factor, and then leveraging technology to help overcome that factor will hopefully help us achieve some of the goals that are set out within power.
One of the things in a macro sense is going away from time-based maintenance to condition-based maintenance, right? You get the data from the machine tells you when she or he is sick, you go and fix it. It's changing dramatically. Well, that's kind of in a macro sense. On a more micro sense, what are some of the examples where you've seen the problem and you've had to come up with a technology solution, or you've had to support a technology solution for that? I know that's hard because there's 1,000 you can pick from, but let me drive it to an area.
Yep.
Distributed energy resources, wind and solar.
Yep. They
are problem creators, opportunity creators,
yes.
Right? Talk about that, because that's affecting what you do in a big way.
I might switch my focus on that a little bit, okay, and look at how are we executing some of this, okay, in a way that we can do more with fewer resources and people.
Okay.
Because that is a common theme that we see. We can't get access to the right material when we need it to construct projects on the timelines that the clients that we work for need them. So one thing, like if you're looking at how do we leverage technology to do things a little bit differently in that sense, is what can we automate in our processes that allows us to get designs right the first time, but then not only designing correctly, but doing it in a way that we can leverage some of the same systems to put that product straight into construction, rather than having to always go to paper prints, get those to construction, and then making updates and communicating updates, letting our construction crews build right from the models that we are designing in. And I think that's something that we've seen big changes in. There's industries outside of power that leverage that and have leveraged technology like that for a long time. And we're starting to see that trend more and more. I think that will help us. It'll help us build things quicker, more accurately. But then on top of that, another thing that we really tried to focus on is what can we package ahead of time so that we're not needing to put it together piece by piece in the field. And that helps with supply issues as well, being able to build a substation and then just lay the substation down where we need it to be, so that everything is done ahead of time, cut down construction costs, and helps us achieve some of the interconnections to get the solar and get the wind operating.
In the design part, because I believe I was the president. I retired I'm one of those people that left the industry. I retired from the Electric Power Reliability Alliance. I was the president of that organization. And one of the things we focused on was reliability by design. You build reliability in by design. It's not a maintenance and reliability function. And one of the things from what you just said is to trying to build a package is you build that package based on certain assumptions of power flow, right? Mm-hmm. Now, the neighborhood changes what they do. More people come online with solar. They become prosumers. They want to send you power back up. How do you build flexibility into it? Your eyes is just bugging. Yeah. How do you build flexibility into design?
We have approached this in a few different ways.
Okay.
But one thing we like to talk about is, building for not what we need today, but what we might need in the future. So yes, it's going to be more of an investment now, but in the long run, especially if you look at where things are trending, it will save costs and save time if we're able to optimize, if we're putting in a 115 kV line, can we maximize what that is capable of so that we don't have to come back and replace it when we need more time?
Yeah, it's a little bit like what back in the day we used to overbuild everything. Yep, we could do that. But people don't want to pay for overbuilt systems, right? Hey, I want that capability, but I don't want to pay for it. Unless it becomes part of the model. And the model being, things are going to change on this end, and we have to build that flexibility. And that's a buzzword that's happening more and more in the industry. We must build a flexible grid. And you just talked about what a flexible substation looks like. You got to be able to take into account the future as power flow. You mentioned people. We all know we've got a brain drain. We all know there's not enough people coming there's not enough women coming into it. There's as many women in the world as there are men. So why aren't we getting more women? And it starts at STEM, and it's really, give me a commercial for women in power systems.
So I think we've gotten better within the power industry at this. And when I say at this, I mean talking about it. So when kids grow up, what do they want to be? They want to be what they see. They see doctors, they see policemen, they see firefighters, they see astronauts, right? And all of those things are talked about at ages that it resonates with them. And the things that resonate with them tend to be the impact that they're able to have on the communities they serve. And so I think within the power industry, communication, as you can imagine, with a bunch of engineers has not always been our strong suit. And we tend to be pretty humble. So we don't talk about what we do. So if you go ask the average person, they probably couldn't tell you all the ways that an electrical engineer impacts the communities they serve. And so talking about it more in that sense, and really, I think, connecting with this is how you can make a difference in the power industry, how you can make the world a better place, is a start. And I think we've gotten a little bit better at that. Yeah, we still have a ways to go. But then also just getting out there in front of girls. So I talked about how we did a STEM outreach event yesterday, and we ordered pizza, had a bunch of Girl Scouts come in and students from across the Kansas City communities, and they were just excited to be there. Half of them they probably didn't even know what engineering was, but by the end of it, like, everybody was asking so many questions. And what intrigued them is what we get to learn about, what we get to do, and how we use that to make a difference in the lives of people. So I think sometimes people feel like it's a really big barrier to even have those touch points, but reach out to your local communities, buy a couple boxes of pizza, bring in one female leader or engineer, and just let them have a conversation. I think it makes so much of a difference, even more so than we probably realize.
Were you the keynote at the Girl Scout gathering? Right?
There were a few of us.
Excellent, because the more we bring people say this is a norm, it's not. Yeah. And we started doing work on women in power systems, and I see the change. I'm beginning to see more younger females coming into it. Still not anywhere near as what we need, but the same is true. We need more men coming into it, and a lot more people coming into the solutions part of this. The biggest thing is, you want to make a difference, come into the power industry, because electrification of everything is making a big difference. Last series I want to go on is you're at the Seagray Symposium, U.S. National Committee. What is the value of Seagray to you and to Burns and McDonnell?
So I've been involved with Seagray for the past 10 years now.
Okay.
I started my involvement not knowing what the organization was, which is a shame. But I think we've grown our presence within the U.S. to a point where most electrical engineers, when you say Seagray, they've at least heard the name. But what I love about Seagray is that it's a community of people that you get to grow with throughout your career. You get to build relationships with and really learn from this. The engineering community, especially within the power system space, is small. It sometimes can feel large, but it's small. And so you get to really have and grow those relationships that can make a difference long term. And you never know, they might lead to the next innovative thing. So I'll give you an example. We have a next generation network within Seagray, and it's meant to bring those early career professionals in and get them engaged with the mission of Seagray, which is essentially we want people placed within working groups, working with experts across the globe to talk about real world problems, document them, and provide solutions that have been put in place across the world. But that was my entry point into Seagray, and the group of people that I met that first year, I'm still really good friends with. And everybody kind of, it's a small business or a small grouping of businesses, but you can follow people throughout their careers. And so one of my good friends ended up going to a startup company, new technology. And now I'm able to work with them to say, hey, this is a promising technology that I think can make a really big difference within the grid. How can we support you? How can my company support your company? And I think we can help enable them as a startup technology to expand their product on the market and then help solve some of these big challenges that we're facing with transmission capacity. But without that relationship, that dialogue would have been a lot more difficult. And I think through those relationships, we can really enable a lot of the technology advancements and implementation of that technology that needs to take place as we transition our grid.
That's a great example of the network and the power of the network. It's a global community. I mean, and back in the day, when I say back in the day, I'm talking about when I first came into it, the only way you could talk globally was on the phone, and half the time that didn't work. Now you can Zoom call and you can create a collaborative environment where you can work with people around the globe and keep in contact. So the networks can get stronger. I'm not saying that Zoom is actually good, but Zoom is great, right? My point, we survived COVID with Zoom. But the idea that you can build collaboration and you can build networks and do that. So thank you for that work. I appreciate it. We will be in touch about women in power systems because I will know the editors of that will want to profile you. But thank you. Appreciate it, Mandy.
So appreciate your time.